Okay, welcome back. So we're going to now look at an example where we find the range of the unknown for a line to intersect a curve at some given number of points. So very simply, just now we earlier said that when you have a quadratic curve and a line, the resultant equation after you substitute them together will actually, you can usually use the discriminant to actually figure out whether it intersect or not. Right, so now we have a question here where we want to find a range of values of k. Range of values of k. Okay, for which the line does not intersect the curve y equals to x squared plus 3x minus 4. So we know that when a line does not intersect a curve, okay, the resultant equation, I say again, the resultant equation, okay, it's b squared minus 4ac would be less than 0. So your first step is in fact, my less than 0 didn't come out. Okay, your first step is in fact to find the resultant equation. So we have y equals to 2x minus k, that's equation 1. Okay, you might want to write that down. Maybe I should shift it up a little bit. Okay, not equation 2. Okay, and then we have y is equals to x squared plus 3x minus 4, which is equation 2. In fact, we're going to equate them together because when you equate them together, you will get a resultant equation, and the resultant equation will be in terms of k. So 1 is equals to 2 because of y. So we have 2x minus k is equals to x squared plus 3x minus 4. And then you kind of like just manipulate it. You will have 3x squared plus 3x minus 2x minus 4 plus k equals to 0. It's very important that you make the resultant equation, the right hand side, to be equals to 0. So I will have x squared. I actually skip a lot of steps of manipulation here. So do take note on some of the little things that I did not do. So once I have the resultant equation, I can actually use b squared minus 4ac. So I would say for y equals to 2x minus k do not intersect the quadratic curve, which is y equals to x squared plus 3x minus 4, b squared minus 4ac must be less than 0 for the resultant equation. Okay, equation is a short form for e, q, and underscore, and hence we have b squared minus 4ac must be less than 0, right? So we b is 1 square minus 4 times of 1 times k minus 4, and this must be less than 0. We have here that I will have a negative 4 times k minus 4 will be less than negative 1. K minus 4 is more than 1/4, and k will be more than 1/4. So the range of values of k, okay, must be more than 4 whole 1/4 for it to not intersect. That's all. Okay, so that's a very straightforward example. Oh, and part 2, you need to state the value of k for which the line y equals to 2x minus k will be a tangent to the curve. So what's a tangent? So for all quadratic curves, you can actually draw a line, and if a line meets the curve at one point, you can say that the line is a tangent to the curve at that point. So something to take note here: if a line meets the curve at one point, this is actually a definition. At one point, the line is a tangent to the curve at that point, at that particular point. Okay, so it works for all kinds of quadratic equations, quadratic curves, so on and so forth. So since it's tangent and we know, so we can say, or actually I use up quite a lot of space. So for y equals to 2x minus k to be tangent, I'm just going to save some space, tangent to y equals to x squared plus 3x minus 4. b squared minus 4ac must be equals to 0. So we have that it will be 1 squared minus 4 times 1 times k minus 4 equals 0. We have that, okay, it's actually almost the same step, equals to 1. I skip a few steps and then have k minus 4 which is equals to 1, and 1 over 4, and k must be equals to 1 over 4. So the value of k is in fact 1 over 4 for it to be tangent to the curve y equals to x squared plus 3x minus 4. So that's all for this example, where we look at how we find range of values for a linear equation intersecting a quadratic curve. That's all.